We have single line sections and double line sections. During their introduction, these sections are sufficient to carry the trains properly from one end to other. But over the years, number of trains increases because of many reasons, and these single line, double line sections traffic density gets saturated. When this happens, various means are to be studied for increasing the line capacity. In double line, one of the hindrances for increasing line capacity is the ruling block section. Ruling block section is the section which is normally the longest block section in the line between two important stations. Usually, the train takes more time to clear this section than other sections. If two trains are following one another, the second train and its following train, if any, are to be stopped till the first train clears the longest block section, and this continue further. Under absolute block system of working, no train shall be allowed to leave a block station unless line clear has been obtained from block station in advance. On double line, line clear shall not be given unless the line is clear not only up to the first stop signal at which such line clear is given, but also for an adequate distance beyond it. In absolute block system of working, only one train can be allowed to enter into the block section. A second train can be sent only on clearance of block section by last preceding train. This affects the section capacity, where the density of traffic is very heavy and the block section is the ruling block section, since trains take more time to clear the ruling block section. Intermediate block signaling is a signaling arrangement on a double line section for increasing the section capacity by splitting of a long double line section or ruling block section into two portions called as rear section and advance section. It is a substitute to C-class station working. So, as to increase the section capacity to meet the traffic demand, the ruling block section or long block section on double line is divided into two portions with IBS arrangement. Intermediate block signaling exists only on double line section. Intermediate block signaling is a replacement to C-class station because of the following advantages. Block instruments are not required. Station master and operating staff are not required. Station building is not required. Section capacity is further increased. IBS splits the long block section between the two stations into two sections. Rear section, also known as axle counter section. Advance section. With intermediate block signaling arrangement, two trains can run in the section between two adjacent stations following all the conditions required for absolute block system. The purpose of intermediate block signaling is to increase the section capacity. In an intermediate block signaling arrangement, a long block section between two adjacent stations is divided into two portions with IB signal in between. IB signal is located in such a way that the travel time for the train will be equal for both the sections. Rear section is controlled by last stop signal. Advanced section is controlled by intermediate block signal. Both LSS and IBS are operated by the station in rear. Axle counters with resetting arrangement for rear section in each direction. Axle counter used may be a universal axle counter or a single section digital axle counter. Each block station has an IBS panel with various indications and push buttons. IB signal, IB distance signal and IB inner distance signal are used as per the section requirement for each up and down directions. For convenience, only one distance signal will be shown hereafter. Each block station has a conventional double-line block instrument. IBS is interlocked with line clear obtained with this double-line block instrument in rear station. Magnetotelephone communication is provided from up and down IB signals to respective stations at rear for communication between the loco pilot and station master in rear in case of IB signal at on for more than 5 minutes. Rear section is the section between last stop signal and intermediate block signal, including 400 meters of block overlap beyond intermediate block signal. Entry of train into the rear section is controlled by rear station last stop signal. Last stop signal is controlled by clearance of the axle counter section. Axle counter with resetting arrangement for rear section is kept available at rear station in case of universal axle counter. With digital axle counter, they are available at both stations. Advanced section is the section between intermediate block signal and first stop signal of station in advance, including block overlap. Entry of train into the advanced section is controlled by intermediate block signal. Intermediate block signal is controlled by line clear obtained by double line block instruments at the rear station. Intermediate block signal is taken off by station master at the rear station. Axle counter with the reset system for each rear section is provided. The axle counter may be universal axle counter or single section digital axle counter. Nowadays, axle counter for block proving is also provided for advanced section or intermediate block signal section. Magnetotelephone is provided at intermediate block signal for communication with the station and rear in case IBS is found at danger for more than 5 minutes by the train loco pilot. The last stop signal at the station A can be cleared if axle counter section is clear. In case of end cabin, working clearance of last stop signal also requires station master slide control. Last stop signal will be replaced to on as soon as the train occupies first vehicle track circuit of last stop signal. When train goes beyond last stop signal and on occupation of LSS control track, last stop signal is replaced to on and K2 indication along with a bell will be displayed at station A, operation place, either cabin or station, as a reminder to put back LSS lever or switch to normal. The down intermediate block signal is controlled by a lever in the station A or a signal switch or button on operating panel of station A, and also by the line clear received by station A from station B on the double line block instrument connected between them. On receiving line clear at station A, the intermediate block signal can be cleared. Once IBS is off, IB distant or inner distant signals also display their off aspects. When train goes beyond intermediate block signal and on occupation of IBS track, intermediate block signal is replaced to on and K3 indication along with a bell will be displayed at station A operation place as a reminder to put back IBS lever or switch to normal. When train goes beyond intermediate block signal and 400 meters overlap, the last stop signal of station A becomes free. Last stop signal of station A can now be cleared to admit a second train into the rear section or LSS controlled section. As the first train occupies the track circuit in advance of IB signal, the intermediate block signal is replaced to on, where the axle counter IB will be replaced to on only when the train travels 400 meters in advance of IB signal. Train entering signal is to be given by station A to station B when IBS track circuit is cleared by the train. Handle will be turned to train on line at the receiving station. When the train reaches block clearance point in advance of home signal at station B and on getting train arrival buzzer, the block handle will be turned to line closed by station B. A fresh line clear is to be granted by station B to the second train, which is now travelling between LSS and IB signal, for taking off intermediate block signal. Procedure to be followed by loco pilots in case of intermediate block signal at danger or blank. According to General Rules 3.75, intermediate block signal at danger or blank, the loco pilot has to wait for 5 minutes and contact on telephone provided on IB signal post with station master or operator in rear. If authorized by the station A to pass the IB signal at danger on exchanging of private numbers, he can pass signal at danger and proceed to station B at normal sectional speed. If communication is not possible after waiting for 5 minutes, he can go beyond IB signal at a speed of 15 km per hour. If visibility is clear, or 8 km per hour in case of inadequate visibility, fog, night, etc. The loco pilot should proceed at restricted speed till he reaches station B and report failure to station master. On arrival of the train and after failure, rectification system should be reset by the joint cooperation of both the station masters. At station A on IBS panel, the following indications are provided. Axle counter portion is occupied or cleared. K1 indication and buzzer, intermediate block signal is passed at danger by a train. K2 indication and bell. Train occupies LSS track circuit, but LSS lever or switch is still reverse. K2 indicator is reminder to the operator to put back the signal to normal. K3 indication and bell. Train occupies the IB replacement track circuit, but IBS lever or switch is still reverse. K3 indicator is reminder to the operator to put back the signal to normal. K4 indication and buzzer. IB signal goes blank, neither red nor green. There are two types of cancellations. One, when a train passes IB signal at on. Train has passed IB signal at danger, which is indicated by K1 and buzzer. SM of receiving station pressing the PB3 button and SM of sending station pressing the PB1 button at the same time till such time the K1 indication disappears. After this cancellation recorded by a counter, the LSS can be re-cleared again. When axle counter fails, axle counters fail to show the clear indication when the train has fully cleared the 400 meters overlap in advance of IB signal. Cancellation of axle counter done jointly by SMs of station A and B only after the train has arrived completely at the station and so verified by SM of station B. Station B has to press PB3 and station A has to press PB2 simultaneously till such time the axle counter shows clear indication. This cancellation, also recorded by a counter. This procedure is used with universal axle counter with SSDAC preparatory reset method is used. Preparatory reset method with SSDAC. Whenever the LSS section axle counter remains occupied and does not clear even when there are no axles left behind in the section. Axle counter has to be reset and this is done by inserting SM key in the reset box and key has to be turned along with pushing reset button. After resetting is done by station masters at both stations, LSS PPR relay picks up after a time lapse of 12 seconds. When LSS PPR relay picks up, preparatory reset indication, yellow, appears on both SSDAC reset box as well as reset counter increases by one number. Now, the next train has to be piloted out into the rear section as the axle counter was in preparatory reset mode. When this train enters and clears the rear section, LSS section, LSS VPR relay picks up the clear indication will be displayed on the panel as well as the SSDAC box. Similar preparatory resetting method is also used for block proving axle counter failure. Last stop signal track proving relay LSS TPR. LSS Replacement Track Relay. With LSS off, when LSS TPR drops, it registers the entry of train into block section. Axle Counter Proving Relay ACPR. This will drop when rear section is occupied. That is, when a train passes LSS signal and enters into the block section. This relay picks up when axle counter section is free of axles or vehicles and LSS controls. That is, LSS lever or switch, LSS slot and concerned relays are made normal after the passage of the train. LSS-DR. LSS signal off aspect controlling relay picks up when LSS-YR is up and LSS lever or switch is reversed. Last stop signal, slot relay, LSS-YR. This relay controls LSS clear aspect relays, LSS-DR. LSS-YR picks up by proving SM slot is received, SM-YR up rear block section is clear, ACPR up, IBS working properly, ACZR up and HSR down. LSS track circuit and IBS track circuit are clear. LSS TPR up and IBS TPR up. Last stop signal, section stick relay, LSS SR. This proves the positive entry of a train into the rear section and not due to bobbing or failure of the LSS track circuit when LSS is taken off. This is the rear section, first sequential relay. This relay drops when a train enters into the rear section by LSS TPR down. It picks up by proving the train entry into the rear section and on clearance of LSS track, rear section is occupied. LSS SR picks up through LSS TPR up, ACPR, LSS VPR down with SSDAC. ACPR, EVR and SUPR down in case of universal axle counter. In other words, it proves the correct working of LSS TPR and axle counter relays, that is, LSS, VPR and ACPR relays with SSDAC or ACPR, EVR and SUPR with universal axle counter. This relay once picks up, it will be held up by stick circuit. Last stop signal. Section Normal Stick Relay LSS NSR. This is the second sequential relay of the rear section. It drops on entry of a train with LSS off, LSS TPR down. It picks up when the rear section is cleared by the train and LSS controls, that is, LSS lever or switch. LSS slot and concerned relays are normal. LSS NSR picks up with LSS SR up and ACPR up. It will not drop due to LSS track circuit failures when LSS is not taken off. IBS Line Clear Proving Relay LCPR. This relay picks up at train sending station when line clear is received by the double line block instrument for clearing intermediate block signal. Stick relays ASR1 and ASR2. These are the stick relays in connection with double line block instrument and intermediate block signal. Drops when train passes intermediate block signal and occupies IBS track circuit. They pick up at station A when train clears the IBS track circuit and block instrument handle at receiving end turned to train on-line condition, proves the proper sequence of train line block instrument operation, that is, after granting line clear and on train entry into the block section receiving end double line block instrument handle turned to train on-line and gets locked. Intermediate Block Signal Track Proving Relay IBS TPR. IB Signal Replacement Track Relay. IBS-DR. Intermediate Block Signal Off Aspect Controlling Relay. Picks up when line clear, LCPR, is received along with other controls. Intermediate block signal distant relay IBS DDR. Intermediate block distant signal clear aspect relay. Intermediate block signal stick relay IBS HSR. This relay is normally de-energized and it picks up when the IBS is taken off for the train. In the rear section, IBS HSR picks up with ACPR down and IBS DR, IBS DECR up. This relay has a stick circuit and will be in pickup condition until the train clears the IBS track circuit. This relay helps ACZR relay to remain in pickup condition when the train passes from rear section to advanced section, passing IBS and IBS track circuit. This relay proves the proper working of intermediate block signal and hence proved in LSSYR circuit. Intermediate block signal pass at danger relay ACZR. This relay is normally in pickup condition. It drops when a train passes intermediate block signal at on position. When it drops, makes K1 indication along with the buzzer actuated at the sending station to alarm the danger. Its pickup contact is used in LSS YR circuit. Hence, as long as ACZR relay is down, LSS cannot be taken off for the next train. And the section between station A and station B should be treated as one section and only one train will be allowed between the two stations. ACZR again picks up after rectification of the IBS failure and cancellation of train passing intermediate block signal at the danger condition by the cooperation of two station masters. ACZR does not drop if train passes IBS with signal at off position. Cooperation of receiving relay CRR. This relay picks up at sending station when PB3 button is pressed at the receiving station to cooperate with the sending station for cancelling either intermediate block signal past a danger cancellation or axle counter cancellation in case of universal axle counter. ACZNR. Train passing intermediate block signal at danger, cancellation button relay at sending station. ACZNR picks up at sending station when PB1 is pressed with ACZR down. ACZNPR. Train passing intermediate block signal at danger. Cancellation relay picks up when sending station presses PB1 and receiving station presses PB3 simultaneously. ACZNPR picks up with ACZNR up, PB1 pressed at sending station, and CRR up, PB3 pressed at receiving station. Axle Counter Resetting Relay, ACRSR. This relay is used for resetting axle counter working. This relay is used with Universal Axle Counter for IBS. With SSDAC, this relay is not required. Whenever the axle counter shows occupation, even when there is no axle or vehicle is left in the axle counter track portion. It picks up when sending station presses PB2 and receiving station presses PB3 simultaneously. When ACRSR picks up, feed is extended to R relay inside the axle counter evaluator and resetting takes place. Push button proving relay, PBPR. This relay is used for silencing the buzzer actuated when intermediate block signal is completely blank. When intermediate block signal is passed at danger. LSSRR. LSS section switch reverse relay. This relay picks up when LSS switch is made reverse. and the relay drops when LSS switch is made normal. LSS VPR, LSS section or rear section vital proving relay. When LSS section or rear section is clear of axles, LSS VPR relay picks up at both station A and station B. LSS VPR relay pickup is indicated by clear indication, green on the panel, and section clear indication, green on the IBS SSDAC reset box at both station A and station B. Whenever the section is occupied, LSS VPR relay drops at both station A and station B. LSS VPR relay drop is indicated by occupied indication, red, and section occupied indication, red, on the IBS SSDAC reset box at both station A and station B. LSS PPR, LSS section or rear section preparatory reset relay. This relay is normally down at station A and station B whenever the LSS section axle counter remains occupied and does not clear even when there are no axles left behind in the section. Axle counter has to be reset, and this is done by inserting SM key in the reset box, and key has to be turned along with pushing reset button. After resetting is done by station masters at both stations, LSS PPR relay picks up after a time lapse of 12 seconds. When LSS PPR relay picks up, preparatory reset indication, yellow, appears on both SSDAC reset box as well as reset counter increases by 1 number. Now, the next train has to be piloted out into the rear section as the axle counter was in preparatory reset mode. When this train enters and clears the rear section, LSS section, LSS VPR relay picks up the clear indication will be displayed on the panel as well as the SSDAC box. IBS RR, Intermediate Block Signal Switch Reverse Relay. This relay picks up when IBS switch is made reverse and the relay drops when IBS switch is made normal. IBS VPR, Intermediate Block Section or Advanced Section Vital Proving Relay. When IBS section or advanced section, which is controlled by double line block instrument, is clear of axles, IBS VPR relay picks up at both station A and station B. IBS VPR relay pickup is indicated by IB axle counter clear indication, green on the panel, and section clear indication, green on the SSDAC reset box at both station A and station B. Whenever this section is occupied, IBS VPR relay drops at both station A and station B. IBS VPR relay drop is indicated by IB axle counter occupied indication red and section occupied indication red on the SSDAC reset box at both station A and station B. IBS VPR relay drop is indicated by IB axle counter occupied indication red and section occupied indication red on the SSDAC reset box at both station A and station B. IBS PPR. This relay is normally down at both station A and station B whenever the block proving axle counter section remains occupied and does not clear even when there are no axles left behind in the section. Axle counter has to be reset, and this is done by inserting SM key in the reset box, and key has to be turned along with pushing reset button. After resetting is done by station masters at both stations, IBS PPR relay picks up after a time lapse of 12 seconds. When IBS PPR relay picks up, preparatory reset indication yellow appears on both IBS SSDAC reset box as well as reset counter increases by 1 number. Now, the next train has to be piloted out into the advanced section as the axle counter was in preparatory reset mode. When this train enters and clears the advanced section, IBS VPR relay picks up and clear indication will be displayed on the panel as well as the IBS SSDAC box. Non-railway electrified area. Power supply is needed at intermediate block signal location, 230 or 110 volt AC for controlling signal lighting and 230 24 volts for controlling relays and 230 24 volts for axle control track devices. The details of power supply arrangements for intermediate block signal includes 25 mm aluminum power cable, which is laid from the station A and station B to take 230 volts AC from both sides to the intermediate block signal location, in addition to this local power or solar power supply arrangement with an auto changeover switch among these three supplies from where it can be stepped down to 110 volts AC for signal lighting, and also used for the battery chargers for charging the batteries. Railway electrified area. The power supply 230 volts AC is trapped from the auxiliary transformers from both up and down supplies as intermediate block signal location along with local supply or solar power supply with auto changeover facility among these three supplies. The following cable requirements are needed for intermediate block signaling. Power cable. 1 PET quad axle counter channels. 12 crore cable, 2 crores for IBS DR, 6 crores for repeating relays, that is DECPR, RECPR, IBS TPR, 2 crores for cancellation buttons between station A and station B. Paper quad pair for telephone. 6 crore between IB signal and distant signal. IBS distant DR relay. LSS SR QN1 type. This relay monitors the correct working of first vehicle track circuit, that is LSS TPR. LSS SR relay is normally in pickup condition. It drops when LSS TPR is occupied. Then picks up when LSS TPR is cleared and the section ahead is occupied. Once picks up, it has to stick circuit through LSS TPR up and its own front contact. LSS NSR up contact in the stick circuit will not allow this relay to drop due to track relay bobbing when the LSS is normal. ACPR. This relay will remain in pickup condition when the rear section is free of any vehicle. This relay drops as soon as train enters into the rear section, that is, by dropping of LSS TPR relay. And picks up when the rear section gets cleared by picking up LSS TPR, LSS SR and LSS VPR relays. And LSS controls are made normal, that is, by dropping of LSS YR, LSS DR, LSS switch relay, LSS RR. LSS NSR. This relay is normally in pickup condition, proving that the track circuit and axle counter connected with rear section are clear and LSS signal controls are normal through LSS SR up and ACPR up. Drops when train enters into LSS section. When LSS signal is given, LSS RR drop will not be available for LSS is taken off when LSS TPR drops by the occupation of train. LSS SR up and ACPR will not be available. It picks up when the train clears. LSS TPR, LSS axle counter section, and when signals are made normal by LSS SR up and ACPR up. The stick path through LSS RR down and LSS NSR up when LSS is normal does not allow this relay to drop due to LSS TPR bobbing or bobbing of axle counter controlling relays for any reason. This relay proves the integrity or correct working of LSS TPR and axle counter control relays. LSS YR. This relay picks up when both LSS and IBS controlling tracks are clear, LSS section axle counter is clear, and IBS is working properly, that is, ACZR up and HSR down. In case of end cabin working, SM slot also included in this circuit. This relay controls LSS-DR relay and thus the off aspect of last stop signal. LSS-RR. This relay controls the last stop signal operation. This relay picks up when LSS switch is made reverse and the relay drops when LSS switch is made normal. Once RR picks up, even if station master key is removed, that will not drop LSS-RR relay. Now, even without SM key, if LSS switch is made normal, LSS-RR does not drop. To drop LSS-RR, switch has to be made normal with SM key in. LSS-DR QN1 type. The contacts of LSS-YR are used for picking LSS-DR, ensuring the LSS control switch lever is reversed. LSS-DR controls the feed to the LSS signal. IBS-RR. This IBS switch reverse relay controls the IB signal operation. This relay picks up when IBS switch is made reverse and the relay drops when IBS switch is made normal. Once RR picks up, even if station master key is removed, IBS-RR relay will not drop. Now, even without SM key, if IBS switch is made normal, IBS-RR relay does not drop. To drop IBS-RR with SM key in, IBS switch has to be made normal. IBS-DR QN1 type. IB signal green aspect controlling relay picks up when line clear, that is, LCPR is received, and along with other controls. Normally, when the double line block instruments are in line closed condition, ASR1 and ASR2 relays are in pickup condition, that is, proving that earlier line clear granted was used, that is, instrument after entry of train into the block section was turned to train on line condition and got locked. When station B grants line clear to station A, station B bottom needle and station A top needle to line clear, PR relay LC contact is made. IBS LCPR relay picks up proving line clear contact LC. ASR1, ASR2 relay up. IB section is clear when BPAC is available by IBS VPR up. IBS TPR up and IBS is normal, that is IBRECR is up. Once IBS LCPR relay is up, it bypasses IBS-DR and IBS-RR relay drop contact, IBVPR and IBRECR relay up contact as shown above, as signal is going to change its aspect from on to off. IBS-DR relay will pick up when IBS signal is taken off along with IBS-LCPR is up, IBS-TPR up, ASR1, ASR2 up, IBVPR up, and ACZR relay is up. IBS is working properly. When IBS-DR up, IBS signal display off, aspect, with IBS DCPR up, LCPR up contacts in IBS-DR relay circuit are bypassed to prevent failure of IBS-DR relay circuit in case of premature operation of double line block instrument from the line clear to train online. When train passes IBS and occupies IBS-TPR, all relays, that is, IBS-LCPR, ASR1, ASR2, IBS-DR relays will drop, and this gives K3 indication and bell as remainder to SM to put back IBS switch or lever to normal. IBS switch is made normal, IBS-RR drops. Train entering signal, that is, 3 bell beats, will be exchanged between station A and station B. Station B turns double line block instrument handle to train online and gets locked in train online position. At station A, PR relay train online contact makes. ASR1 and ASR2 relays pickup proves train has completely inside the block section. That is, IBS-TPR up, IB signal is normal. That is, IBS-DR, IBS-DECPR relays down, and IBS-RR relay down. Granted line clear was consumed. That is, block handle at other station is locked and LCPR is down. Unless proper sequence is followed in closing the block section, clearance of IBS signal is not possible. Even when PR train online contact break ASR1 and ASR2 has its own stick circuit. Through IBS-TPR up and the second path through LSS-NSR up, LCPR down, the path does not allow ASR1 and ASR2 to drop even when IBS-TPR bobs. ASR1 and ASR2 proves one train and one signal for sending next train into block section. A fresh line clear has to be taken, which is possible only when handle is released from its locked TOL position, and that is possible when train arrives to station B. IBS HSR. This relay is normally de-energized. It will pick up when IB signal to be given IBS-DR up and IBS-DECPR up. To a train on approach to IBS ACPR down. It will be in pickup position even when train passes on IBS track circuit, drops when train clears IBS track circuit. This relay keeps the information that IBS is working normally and help to maintain ACZR relay up. When a train passes IBS at danger, this relay does not pick up and make ACZR to drop to register this abnormal condition. ACZR. This relay normally in pickup condition. This relay feed is taken through 3 paths and when a train passes IBS with off condition, at least one of these three paths available and ACZR in pickup condition. When a train approaches IBS signal, LSS NSR up will not be available till it clears IBS TPR. When train is in rear section and IBS is a danger, HSR up will not be available. When a train passes on IBS TPR with the above conditions, IBS TPR up, HSR up and LSS NSR up will not be available and makes ACZR relay to drop to register the abnormal condition of train passing IBS a danger. As long as ACZR relay is down, LSS as well as IBS cannot be cleared. In this case, LSS section and IBS section should be treated as only one section and trained to be piloted accordingly. After IBS signal rectification, signal passing IBS condition has to be resetted with the cooperation of both station masters. Then ACZNPR picks up and circuit for ACZR will be completed and ACZR relay picks up. Now normal working of IBS will be restored. CRR. This relay picks up at sending station when PB3 pressed at receiving station for cooperation of either axle counter cancellation or IB signal passed at danger cancellation. ACZNR and ACZNPR. Train passing IB signal at danger, cancellation relay ACZNR picks up. And PB1 at sending station is pressed. ACZNPR picks up with ACZNR up, PB1 pressed at sending station and CRR up, that is PB3 pressed at receiving station. PBPR and XR. This relay is used for silencing the buzzer. 1. IB signal passed at danger. When train passes IB signal at danger, buzzer gets activated through PBPR drop contact. When PBPR relay up, buzzer stops. PBPR relay will drop when IB signal passed at danger, failure is rectified and reset operation is done by ACZR relay pickup. 2. IB signal is completely blank. When IB signal is not off, red aspect is to be displayed. If for any reason red aspect is not lit, IBS RECR drops. This will complete the path through XR drop contact for buzzer. When this failure is acknowledged, XR relay picks up and buzzer stops. XR relay has stick path as long as failure continues. When failure is rectified, XR relay drops. Similarly, when IBS DR is up but green aspect is not lit, IBS DECR will not pick up this condition. Also actuates this buzzer with XR drop contact. Indication. K1 indication. When IB signal is passed at danger, ACZR relay drops and K1 indication appears along with a buzzer. K2 indication. When LSS is taken off and train enters into the LSS section, ACPR relay drops and LSS switch is still reverse. K2 indication appears along with a bell to remind the SM to normalize the LSS switch. K3 indication. When IBS signal is taken off and train enters into the IBS section, ASR1 and ASR2 drop, and if IBS signal switch is still in reverse, K3 indication appears along with a bell to remind the SM to turn the IBS signal switch to normal. K4 indication. Whenever IBS signal is blank, K4 indication appears along with a buzzer. 1. When IBS signal is on and IBS RECR is dropped. 2. LSS is off. 1. LSS at danger. 2. LSS is off. Preparatory resetting circuit with SSDAC for LSS section and IB section with BPAC. The LSS section axle counter system has been provided with preparatory reset feature. In case of failure, reset is to be applied by both station masters and the system comes to a preparatory state. One train is to be piloted in the section for system to become clear and normal. Procedure for piloting should be followed as per station working rules, SWR in railways. Vital relay, VR, and preparatory relay, PR, are provided in the relay box installed at SSDAC system location box. VPR and PPR are their repeater relays. Preparatory resetting relays PR and PPR are normally down relays and vital relays, which proves that the axle counter section is clear. That is, VR and VPR are normally up relays when the axle counter system is failed. VR and VPR relays drop. Through VPR, back contact occupation indication appears on the reset box and red indication appears on the indication panel. SM's resetting operation from both the stations is required with or without time gap in LSS section SSDAC system. To perform this, insert SM's key turn right, keep pressed and press reset button. With this operation, the 48 volts DC from the reset box is extended and connected to the SSDAC through the drop contacts of PPR and VPR relays in relay room. This 48 volts DC activates the reset circuit and modem card of SSDAC unit and generates reset commands to the microcontroller cards of SSDAC unit. Then, the SSDAC units are reset and counts become 0. The self-test is carried out in both the units. After a gap of 5 seconds approx, the SSDAC units attain the preparatory reset state. The PR and PPR relays pick up the preparatory reset LED indication. Yellow glows on the reset box in station master's room and the counter reading also increments by 1 count. In this preparatory mode of SSDAC, one pilot train is to be passed in the section to make the system normal. When a train passes in preparatory mode, then VR and VPR relay pick up and PR and PPR relays drop at both the stations. When PR and PPR relays drop, yellow indication extinguishes, and through VPR front contact, clear indication appears on the reset box and green indication appears on the indication panel.